law, PV equals nRT. If you have pressure, volume, moles, and temperature, you can do that. There's another way for us to look at the molar mass of a gas, and that's using, and I'm going to use this version right here more often than not. So I'm gonna, this is the one I use more often. You're welcome to use the other version, so that's just the one I use. Okay. Molar mass of a gas equals density times your gas constant R times temperature, still in Kelvin, divided by pressure, still in atmospheres. So if I don't know the molar mass of a gas, but I do know its density and temperature and pressure, we can find its molar mass. It's not too far of a stretch, usually just a plug and chug situation. What I found out so far is most people going through the 5.4 homework get so hyper-focused on using PV equals nRT, they totally forgot you can do this. So here's a good ding, ding, ding. PV equals nRT uses moles. Molar mass of the gas uses molar mass. Okay, this is a big key word to help you figure out which one you're going to be trying to use. Right. So let's try this problem out. Density of a gas was measured at, you have a pressure, you got a temperature, and they gave you the density. Try the molar mass. Okay, I'm going to give you a couple minutes to try that out. It's just a simple plug and chug while I do attendance. Brain, Hayden's here, I've seen Troop, Gracie's here. Malika's here. You good, Malika? Yeah. Cool. Ruby back there? Cool. Okay, I'm going to write this out with the units included. The whole point of me is having the units included. You don't need to on your math, but I'm going to do it just to show this should cancel out 2 molar mass. So what's the units of molar mass? Grams per mole, right? So if we do this correctly, the unit should cancel out to grams per mole. So I'm going to annotate molar mass as mm. So let's say molar mass equals density. They use the lowercase d here for density for gas because capital D is usually meant for liquids and solids. But you can use capital D, I don't care too much. We got dRT over P. Not too crazy. What do we got here? I gotta zoom out a little bit. Actually, let's zoom in. Zoom in. see my numbers.
My dad.
Density was told to be 1.95 grams per liter. R constant, still the same number, 0.08206 liters times atmospheres per mole Kelvin. And then temperature, got to convert that to Kelvin. What's that in Kelvin? Should be 300 Kelvin. All over. What's our pressure? 1.5. 1.5 atmospheres. I got atmospheres on top and bottom. Look at that, those cancel. I got Kelvin on top and bottom. Looks, that cancels. And I've got liters on top and bottom. Wouldn't you know? The unit I'm left with is grams per mole. All right, we'll get there one of these days here. Plug in the calculator, round it off. I think we get a pretty answer of 32 grams per mole. Not too crazy. We'll still fly. Yes, officer. I could rob a bank just because it's Friday. That's the same logic, there, man. Okay, we're gonna pivot on to some practice test questions. These questions you should be able to answer in 20 seconds. 20 seconds. There's no math involved. It's just straight conceptual chemistry. What I will do is give you 60 seconds. Okay. And then lock in an answer, and I'll tell you what the answer is. This is a good indicator of how much you've mastered the material so far. 20 seconds. Go. Ten seconds have gone by. And time. Got an answer, bank? Let's look at this. What happens to the density of a gas in a rigid steel container as you heat the gas? So my first thing I'm looking at, well, density is how much mass per volume there is, right? Did I change the amount of the mass of the gas in the container? No. Keywords there, rigid steel container, meaning the volume also what? Cannot change. So when you heat up a gas, does the density change? Nope. What does change, however, though? You heat up a container, rigid volume, pressure goes up, right? But not density. Why not density? Well, because mass and volume didn't change. Everybody know? I was in middle school. My middle school math teacher gave us a test. It was A, B, or C. It was every single question. Somebody said all the answers were D. One kid committed, hit D on every single one. Never forget that kid. got worse than that. Got an answer? Bank it? Let's check it out. If I have a movable piston, density is mass over volume. Did I add any mass to the container? No. We did heat up the container, and we allowed the piston to move. If you allow a piston to move, what can change? Volume. You increase temperature, what happens to volume? It can increase. If volume increases, what happens to density? Decreases. All right, those gas molecules are spread out more. So let's draw a little piston here. I'll draw before gas is added. Dallas, give me a number between 1 and 10. Malachi, give me a number between 1 and 10. 5, okay. If I've got 5 gas molecules in here, 1, 2, 3, 4, 5, I heat up a piston so it can move. I still have 5 in the container, right? Does your mass change? No, we didn't add any gas. But your volume increased, so density goes down. Some people have a hard time seeing this. They might want a picture like this in their brain instead. Can we agree that the molecules in the picture on the bottom are more compact than the picture on the top? Yeah. Okay. Ready for another one? Rolling 2 balloons, each filled the same mass of gas. One has hydrogen, one has helium. Which of the following statements is correct? So I'll draw you a picture. We got helium, or hydrogen, with some mass. We got helium with the same amount of mass. Picture's not drawn to scale. Put the little asterisk down here. Not to scale. You gonna answer yet? Think in your brain. Let's unpack the reasoning or logic on this one. Well, if we look at the molar mass of hydrogen, that's 2 grams per mole. Mass of helium is 4 grams per mole. Uh-oh. Which one of these is going to have, if they're the same amount of mass, are they going to have the same amount of molecules? No, because they don't have the same amount of molar mass. Which one's got more molecules then? Hydrogen. Twice as many molecules, which means the balloon is going to be twice as big. All right, we're going to do one last practice one. Four identical flasks contain the gases helium, hydrogen, methane, helium, chlorine, methane, and ammonia. each at 0 degrees Celsius and 1 atmosphere pressure. Which gas has the highest density? You might need a periodic table on this one. Unless you're just awesome and got the periodic table memorized. You can answer? Did you bank it? Which gas has the highest density? Well, we have one formula in our repertoire now. Molar mass is equal to density, gas constant, temperature, all over pressure. These 4 flasks are at the same temperature, right? They're at the same pressure, right? And the gas constant is a constant. So what are we looking at to figure out which one has the highest density then? Well, whichever one has the highest molar mass, which would be cool. That is official wrap up to 5-4 notes. What I got for you